Hi everyone, welcome back to another Leetcode, and in this problem statement we are going to be doing the square root of x problem here. So basically in this problem statement we're given a non-negative integer x. We need to return the square root, and the square root has to be rounded down to the nearest integer, and it should be non-negative as well. You must not use any built-in exponent function or operator. So we have two examples here. X equals 4. The output is 2 because the square root of 4 is 2. And we have another example, which is x equal 8. The output is also 2. So the square root of 8 is actually 2.8 and some change. So we need to round it down to the nearest integer. So let's look at the simplest solution first. And the simplest solution is basically you have a guess, and you can start at 1, and while the guess squared is less than x, then you can just increase the guess, and then when we find when the guess squared is actually greater than x, we can just say, or equals to s, we can just return the guess. So let's just run this test case, and it looks like we failed the test case. So the first one is 2 to 2, the second one is 3 to 2. So basically let's try looking at the while loop and just increase it by one iteration, and let's run that test case again. And okay, we get both wrong this time. Let's look at the outputs. 3 and 2. Second case is 3 and 2, so at least it's consistent. So basically let's just subtract it by 1, and then we can just run this again. Okay, now we get a passing test case. Let's just submit it. And we have an accepted case here, accepted solution. So this is the simplest solution, and in this case the time complexity is actually O of n, the input of x. Basically if it gets a higher number, the runtime grows as x grows. So O of n time complexity, and the space complexity is actually O of 1. And okay, so this is the simplest solution. Let's look at a more complex one, and one with a faster time runtime. So basically we can, instead of just having one guess, we can have two, not to say two guesses, we can just have a lower limit, and which is 1, and a upper limit, which is x. So that is the possible values 1 to x. Square root is somewhere in the middle. So we have a while loop, and we can say while lower is less than upper. We're going to try and find the square root, and we can say, okay, we can create a midpoint. Let mid equal, let's just floor this thing. So we're rounding it down, and we're going to say upper plus lower, and we're going to divide it by 2. And then we're going to just check if the square is actually the input. So if mid equal x, then we can just return the midpoint. Else if the guess is too small, so mid is less than x, then we can just return, or not return, we can just say, okay, lower equal mid plus 1. Because the guess is too low, so we need to increase the lower bound. So basically the lower becomes higher than the midpoint. And then we can say, okay, else we're going to create the upper equal mid minus 1. So basically what we do is we have a guess. If we get the guess, we return the guess, and then if the guess is too low, we're going to just increase the lower limit and then restart the iteration again, calculate the midpoint, and then check again. If it is higher, then we're going to just decrease the upper point and then recalculate the middle point here and then check. And if this while loop goes through until the completion, we can just return one of it. I think we can just return the upper value, and let's just see if this passes the test case. So we have case one. Case one is actually correct, 2 2. Case 2 is 3 2. Okay, what can we do? Min minus 1. Let's see if we can just change this. Let's see. Okay, let's just increase the. Okay, now we've got it accepted. Okay, let's just submit this, and we have an accepted solution. So this is a little bit more complex. This is basically a binary search. So this time complexity is actually log of x. So because every time you are actually trying to guess, you're dividing it by 2. So that's why the time complexity is log of x, and the space complexity is actually O of 1 as well. So this is the more complex approach. There's actually one more approach that you can do, and it's called the Newton method. So instead of having a guess, so basically having a lower and upper, you can just have a guess again. You can just say, okay, let guess equal x. So we're going to start with the guess at x, and we're going to say while the guess times guess is greater than x, because if we start the guess at x and we square it, it will always be greater than x. So we can start that, and then we can just say, okay, the guess equals, let's see if I remember this, is guess plus x divided by guess, and we divide that by 2. Okay, so let's look at that guess. I think this is right, and then we can just return guess. And let's just run this test case and see if we get the answer. Okay, I got to do something. We should floor this thing, and let's just run it again. Okay, so we got a pass test case. Let's just submit this and see if it it's accept the solution, and we have an accepted solution. So okay, so this is what we call the Newton method. So I'm not really sure why it works, but it does work. So actually Isaac Newton actually created this algorithm. So he probably found out that this theorem, and it's pretty accurate. So you can use this, and the time complexity is actually log of n as well. So the thing about this solution versus the binary search solution, the second solution, is that it's actually easier to explain the binary search. If you're going to use this third solution, you're going to have to be able to explain the math, which is extra work for you to do. So I would basically try to do this solution with either the brute force method, the first solution, or the second solution. So we've come to the end of this video. I hope you enjoyed it, and if you did, please hit the like button and subscribe to the channel, hit the bell for your notifications. If you have any questions, you can drop a comment down below. We're going to do more of these Leetcodes in the future, and I will see you in the next video.